In our project, we realized an IoT system that can be deployed into libraries to achieve different goals. Monitoring and regulating the temperature and humidity in the rooms, which allows both to improve user experience, to reduce energy waste, and to properly conserve, if needed, delicate books. Detecting and turning off lights at desks where nobody is sitting. Allowing users to know in advance the number of available seats and the volumes present in the library. Our system is able to handle independently multiple libraries at a time and multiple rooms for each library. We offer to the library managers a simple text client interface with which it's possible to register a new library, specifying the name and the number of rooms. The system enables a simple login security feature, and it allows to modify for each room some system parameters, such as the desired temperature in the room. All the information concerning the environment of libraries, that is, temperature, humidity, lights, seats, is contained in the library catalog, a CherryPy web server which provides REST functions to perform all operations needed, both for the registration and management of the libraries and of the devices. Once a library is registered, 3 different classes of devices must be registered as well. They are sensors, controllers, and actuators. The sensors are of 3 kinds: temperature and humidity sensors to monitor the environment. These are both implemented with the DHT11 sensor. And pressure sensors to detect if chairs are occupied or not. These were simulated with a digital push button. We imagine that in each room multiple temperature and humidity sensors can be present, in case of large rooms. Moreover, there is 1 pressure sensor for each chair. The sensors are wired to a Raspberry Pi, which provides connectivity through the MQTT protocol. The broker used by MQTT is specified in the catalog. Upon registration, all sensors ask the catalog for the broker address, so that they are able to publish data. The second class of devices are the controllers, divided in 4 categories: temperature, humidity, light, and seats controllers. Each room has 1 temperature and 1 humidity controller. They perform the following operations. They gather data from all the sensors in the room, evaluate the average value, compare it against the threshold which has been set by the library manager, and publish, again on MQTT, the decision to take. Each room has also 1 seats controller, which subscribes to all data from all chairs in the room, computes the number of available seats, and publish it on MQTT. Finally, in each room there is 1 light controller for each chair. Each one of them subscribes to the topic of the corresponding pressure sensor to decide whether the light should be turned off or on. In all cases, the controllers are implemented with threads, meaning that it is sufficient to launch a single script for 1 library, which can simultaneously and independently control all the rooms. The third class of devices is that of the actuators. The temperature and humidity ones were just simulated, while for the light one, a LED connector to the Raspberry Pi was implemented. Each actuator subscribes to its corresponding controller in each room to know which action it has to execute. Periodically, all devices renew their registration on the catalog using REST. If they fail to do that, they are automatically removed from the catalog itself after 2 minutes of inactivity. In addition to the implementation of 1 DHT11 sensor, we simulated, using threads, the presence of multiple sensors, for which random data were periodically generated. It is possible to see the interaction of sensors, controllers, and actuators and their rapid response to a change of the parameters issued by the library manager, who can set a new value of temperature from 1 room. Also in this case, in addition to the usage of the digital button to physically emulate 1 chair, multiple pressure sensors were simulated with threads, The same thing was done for the light actuators, in addition to LID. The ThinkSpeak adapter is used to retrieve all data collected and processed by sensors, and visualize them on dynamic charts. The adapter, in fact, is an MQTT subscriber for temperature, humidity, and seats controllers, and uses REST POST method to upload the aggregated live stream of data on the ThinkSpeak platform. In order to visualize the measured values, a ThinkSpeak channel has been created for each room of each library. Dynamic charts, updated every 30 seconds, can be visualized in real time on the ThinkSpeak channel web page. In addition, data are also uploaded on Freebird, that is an open source tool used for building real-time web-based dashboards. Data are retrieved by ThinkSpeak channel of the room of interest, whose URL is specified in the configuration JSON file of the Freebird. The user can subscribe the bot through the Telegram app. Then he can use the command sign to sign up all the libraries of the system. He is asked to write his personal data. After that, he gets his personal QR code. Before doing any operation, the user should choose a library among all the libraries of the system with command library. It is possible to consult the catalog searching a book by the title, the name of the author, or the publishing house. Thus, the user can retrieve all the information he needs. With the command book, he can reserve a book sending the ISBN, International Standard Book Number. Behind every operation over the library's catalog, there is a web server that exposes the REST methods that use SQLite3 library for searching and updating the catalog. Once you have reserved the book, you go to the library to take. Inside the library, a PC is available to validate your loan. The librarian should select the proper library when the program is initiated. The user can select if he wants to give back or take a book. Then he should scan the ISBN code behind the book and then his personal QR code to associate the loan to his person. Finally, it is possible to know for a given library the number of available seats in each room. A module named Seats Info Controller subscribes to the seat controllers of all libraries and, through REST, it uploads data on the Telegram web server.